So we have here a sequence of squares that is going up in steps. So there's a few different methods we can use to work out what the equation is for this system. But to get us started, we're going to start with a table of values. So with this table of values, it's going to be similar to the table we worked out in the previous section. But in this case, our table is now going to be horizontal. So our first value here, or our first row, will be n, and n just describes the number of the sequence. So n for the first one is 1, that's our first value in our sequence. The second picture is 2, the third picture is 3, and the fourth picture is 4. And that can continue on if it needs to. Our next row in the table is going to be our s values. Now s is defined, and that's just me defining it. I get to define it however I want. S is defined as the number of squares in the pattern. Okay, so in the first pattern here, we see that we have 1 square. In the second, we have 1, 2, 3 squares. In the third, we've got the original 3 plus 3 more, which is 6, not 3. And in the fourth, we have the original 6 plus 4 more. So that's going to be 10. Okay, so that is our table. I'm just going to give that a nice border so it's easier to focus on. So looking at the table, we can see that going from 1 to 3 is a distance of plus 2. Going from 3 to 6 is a distance of plus 3, and going from 6 to 10 is a difference of plus 4. Now it's a really good idea when we have a table set up like this is we don't actually start from 1, we actually start from 0. So I'm going to take these numbers back to when our x value is 0. So we have 4, 3, 2, 1, 0. And working backwards, I can work out what goes in this section here. So we have 10, 6, 3, 1. The next number back, if we look at the differences, we have 4, 3, 2, and then the difference between these two would be a difference of 1. So what plus 1 equals 1? That gives us 0 in this first column. Now the reason we want that is because it's going to make our life easier when we're working out the equation. The standard form of an equation is y equals ax squared plus bx plus c. Now the reason that I know that this is a quadratic sequence is by looking at the values in red here. So we have plus 1, plus 2, plus 3, plus 4, and if we look at the differences of those values, those are plus 1, and plus 1. This second row of values here, the second row of differences, tells us that it's a quadratic. If this was not constant, and we'd have to go back to a third row, then it would be a cubic relationship. So that's how we can know if it's quadratic or not. So we now have our standard form of a quadratic equation, and we're going to work out each of these a, b, and c values. A, b, and c are constants, they don't change, they're coefficients of the equation, whereas y and x do change. To work out the c value, which is the easiest one to work out, that is when x equals 0. So that's why we worked out y, so that's why we went backwards and worked out when x equals 0. So when x is 0, y is 0. That's why we went back to 0 in our table. So that tells us that c equals 0. And now our equation becomes y equals ax squared plus bx plus 0. Now we don't usually write zeros when we write our equation out. So I'm just going to rewrite that as y equals ax squared plus bx. Now, if there was a different number on the end, if c was a different number, then I would just use that number instead. From here, we are going to work out what the values a and b are. To work out these, we need two different equations. So we're going to actually do this next part twice. So first off, let's just pick some values from our table. Those will be our y and x values. Remember, our bottom values here are our y values, and the numbers on top are our x values. So let's take the numbers 1 and 1. 1 is really easy to calculate with, so we're going to start there. So putting those values in, we start with y equals 1. Our x values are also 1. So we're just rewriting the top equation, but replacing the x values with 1 and the y values also with 1. Now 1 squared is 1 times a is just a, so we're left with 1 equals a plus b times 1 is b. That's one of our equations, so I'm going to give that a bit of a box. So now we're going to do the exact same thing, but instead of using 1 and 1, we're going to choose some other numbers from our table. It doesn't matter which numbers we choose, so I'm just going to go with the next one in the sequence, which is 2 and 3. So our y value is 3. We don't know what a is yet. Our x value is 2. So we replace all of these x and y's with 2's and 3's. Let's just simplify that a little. 3 equals, well, 2 squared is 4a, plus b times 2 is 2b. Remember, we usually put numbers before letters when we are multiplying. Now I want these two equations to match as much as possible. So I want either the number next to the a to match or the number next to the b to match. Now in this case we can see that we have 4 a's and 2 b's in this equation, but we only have 1 a and 1 b in this equation. So we're just going to do a little bit of division for our second equation to match our first equation. The easiest way to do that is just to look at these numbers and divide everything in our equation by whatever is the lowest number. So either divide by 4 or divide by 2. The smallest number there is 2, so I'm going to divide everything by 2. 3 divided by 2 is 1.5. 4 divided by 2 is 2. And 2 divided by 2 is 1. And when we're multiplying, we don't usually write 1 times something, so that's just b all by itself. And this is our second equation. So from here, our next step is to take equation 1, that's our first equation we worked out, and minus it from equation 2. So I'll just write that instruction down. Equation 2 minus equation 1. 1.5 equals 2a plus b, that's equation 2. And then we're going to minus all of equation 1. 1 equals a plus b. Now you see I've done this in a vertical way, so the b's line up, the a's line up, and the numbers, the constants, also line up. So starting at the beginning, 1.5, take away 1 is just 0.5. The equals lined up, so I'll just rewrite it equals in line. 2a take away a is 1a, or just a, and b take away b is 0. So we're left with a equals 0.5. We now know what a is. And our last step is to work out what b is. And that's really easy because we can take this new a equals 0.5 and put it into equation 1. 1 equals, this is just rewriting equation 1, a plus b. We now know what a is. A is 0.5 plus b. 0.5 plus what equals 1? B must be 0.5. So now we know what a is. A is 0.5. B is also 0.5 and C is 0. We can take all of that information and put it into the standard form of an equation. So putting that into the standard form, we have y equals, here's our standard form, ax squared plus bx plus c. We now know that a is 0.5. B is also 0.5. And C is 0. And of course, we don't usually write plus zeros, so we can go ahead and delete that plus 0. And here is our final equation. So just a recap of everything we did. We started off with the step pattern and nothing else. From there, we created our own table just based on the step pattern, and we also stepped that back to 0. We found out that this table or this pattern was a quadratic sequence because the second row, or our second lot of changes, is what had the constant values, the difference between +2, +3, and +4. Because it's a quadratic equation, we used our standard form of a quadratic. And because we went back to 0, 0, we knew that the c on the end must be 0. We then used two other values for our x's and y's. to come up with two different equations and work out what A and B is, using a little bit of algebra. And that gave us our final equation. So that is how we form an equation for a quadratic sequence. Now there are other ways of doing this. There are other methods. In the next video, I will show you how to do this, but in a visual sense. It's a little bit more creative and does require some of those creative skills to come through. But it is very helpful if you are more of a picture type person and you can read pictures and patterns quite easily. There is a third method which is popular in New Zealand textbooks. However, I'm not going to cover that because I think it's much more difficult than what we've seen here. So if you can follow along with this sequence here, then you're on the right track. So if you want a copy of these notes, I will leave them down below, and I will see you in the next video.